Hello, thank you for joining or watching this session. DAX is easy until it isn't. Basics for beginners. My name is Paul Turley. I'm a principal consultant with 3 Cloud Solutions, also a practice lead director in our business intelligence and analytics practice. I've been using DAX since it was invented back in 2012, when Microsoft introduced tabular models and analysis services, and then Power Pivot for Excel, and then finally Power BI. DAX is the language that we use to write calculations, and it's an essential language to use when you're doing any kind of analytic reporting with these tools, primarily Power BI these days. I love DAX. I think it's a very powerful language. We can do a lot of very, very interesting analyses and calculations over tabular models that are created with Power BI. But a lot of people, as they're learning DAX, will look at the language and think, oh my gosh, it's simple. It looks just like Excel functions. I can figure that out on my own. And it is simple until they get past the basics and then they hit a wall, can't figure it out and give up. Well, I'm here to tell you that DAX has some fundamental concepts that once you understand, you can move past that first barrier and then start getting into more complex analytics. So we're going to cover the essential building blocks so that you understand the mechanics of the language, how it's used against tabular models, and then how you can use Power Pivot, Power BI, or SSAS tabular to be able to do your own DAX calculations. So let's get started. A little bit about myself very quickly. I actually started out in the TV news business way back in the 80s. And due to an injury, I needed to take a desk job. And so I kind of fell into software development, doing help desk support for a small software startup in the healthcare field. And then eventually found my love with IT training, databases, and then business intelligence. And I just love BI analytics. I've ran my own company. I've worked for some training and consulting companies, and I've been working with Microsoft for a very long time. I've had the pleasure of authoring or co-authoring 14 books and on the topics that we're going to talk about, as well as reporting and database solutions. I've been a member of the Microsoft MVP program since 2009, and I blog at SqlServerBi.blog. Some of the companies that I've worked for, great company, Pragmatic Works. We were a smaller kind of boutique BI consulting firm, and we were acquired by 3 Cloud Solutions a couple of years ago. 3 Cloud has been growing ever since. 3 Cloud is the largest Microsoft Gold Premier partner that specializes entirely in Azure services across the entire spectrum, and I'm part of the data and analytics group, and then the business intelligence and analytics practice within that group. You can download the samples and demo files for this presentation and for other presentations that I've done from my blog, which is at SqlServerBi.blog right there. Just go to the main blog site, and over here in the menu, if you go down to presentations, you'll see all of the presentations that I've done here, and this is updated from time to time as I do additional presentations. So samples, demo files, and the presentation decks, sometimes links to video recordings if those are available. Let's talk about what we're going to talk about in this session. So why is DAX important? It's important to understand some fundamental concepts, things like filters and context, different types of context, which we'll talk about within the presentation. And then once you understand row and filter context, we're going to talk about how different functions in the DAX language are used within those contexts. Aggregator functions, iterator functions, and then this idea of context transition. Here are some of the functions that we're going to use. We will use others, but once you understand these building blocks, you will be prepared to move on and do other advanced things in the DAX language. Now, why is DAX so easy at first and then so hard later on? Well, there's kind of an easy mode. When you get started, DAX just looks a lot like Excel functions, and some of these functions seem pretty easy to figure out. But once you start dealing with filter and row context and this idea of working with and outside of different contexts, that's when things get challenging. So you kind of graduate into a different set of functions. And then once you've mastered that mode where maybe you can write 90% of the calculations that you need to, and then you need to do something special to fulfill some reporting requirement for a business stakeholder, then you find that there's yet another cliff that you have to climb, and that can become a little challenging. So we're going to at least work through that first cliff. One of the fundamental principles within DAX is that it's a table-based functional language, which means that it looks a little like Excel, because Excel is a formula-based or function-based formula language. But the functionality within DAX can also resemble more complex data technologies like SQL, structured query language, or the older flavor of language that was used in analysis services against multidimensional cubes, MDX, or multidimensional expressions. Now, DAX is not purely a replacement for MDX. It's certainly not a replacement for SQL, but you will find some common characteristics and common behaviors within DAX that have their roots in Excel, SQL, and MDX. DAX applies to tabular models. In fact, it's used within tabular models that are part of PowerPivot for Excel. That's the tabular modeling or VertiPaq modeling engine that is used within PowerPivot if you choose to use the PowerPivot add-in for Excel. It's used within Power BI Desktop, and the Power BI service, and it's also part of SQL Server Analysis Services or Azure Analysis Services tabular models. So it's a language that's found in a few places, and because it's such a powerful language, I think we're going to find it in more and more places within the Microsoft data and analytics ecosystem. In 2015, while preparing a training class, I put together this list of DAX functions. At the time, there were about 150 DAX functions. Today, there are plenty more. But it can be a little overwhelming when looking at all of these functions. And the important point here is that it's not important to memorize the syntax of functions. Understanding concepts and the essential building blocks, the mechanics of the language, is far more important than memorizing the syntax of functions. You can always look up function syntax, and oftentimes there are multiple ways to solve a problem. But as you do that, you're going to build examples. You should both find reliable sources of information about DAX, and there are several good resources. Probably most notable are the resources from SQL BI. And once you've done that, and once you've built up your own library, keep those projects around and refer to them. So, it's hard to memorize things. Keeping a library of working examples will be far more valuable than a web search, because unfortunately, not everything you find on the web, if you just Google a DAX function, is going to be accurate and lead you in the right direction. These are some important concepts that we will explore through practice. There are two different kinds of context that are important when thinking about DAX: row context and filter context. Now, these are pretty simple on the surface, and once we get into practice, then understanding how this affects the mechanics of the language and the mechanics of the way that calculations are performed will help you understand how to write effective DAX and understand the behavior of what you are seeing. Row context, in simple terms, is just a matter of what row am I on? What row is relevant or in scope in a particular table? And again, we'll see this when we get into the model, but just remember, row context means what row am I on? What row is selected for grouping or filtering or slicing, which is relevant for a particular table. Filter context is similar, but it answers the question, how is a given table being filtered? As a result of filter propagation from a related table's row context, etc., just remember for now, filter context means how is a given table being filtered. And then the idea of context transition is how row context becomes filter context. And we'll look at some examples. Filter propagation is that transition from a table that has a specific row in context via grouping, filtering, or slicing, and how that row context, that selected row, translates to the filter context of a related table. So we'll look at some examples, and these things will make more sense in application. Now, we're going to approach this from the perspective of Excel. We're going to start in Excel because people understand Excel. Excel is a simple concept. It's a two-dimensional space, rows and columns, and we can create tables just by using ranges of cells. And so that's a familiar territory for most people. So we're going to start by working in Excel. We're going to look at some examples of some simple DAX to explain the concepts that I just talked about. And then we're going to transition from Excel to Power BI Desktop so that you get the experience of working with both tools. So let's switch over to an Excel workbook where I can demonstrate some of these concepts. So we'll just zoom in here a little bit. And here you can see on this worksheet, I have 4 tables. So these are just ranges of cells that have my month information. So I have a month number and a month name. Here I have location information. There's a location ID with the name of a U.S. state. This is very, very simplified data for the purpose of demonstration. But I'm making a point to use key values to represent friendly values that would be used in business. Here are my product IDs that represent product names. And then here's my sales tables. This is a classic dimension tables and fact tables. This is my month dimension, my location dimension, my product dimension. That simply means that it's just a list of values that are used to look up values or to select things or filter things. And then this is my fact table. And the classic fact table in the dimensional modeling world means that I have a table that contains key values related to dimension tables, and then it has some numeric columns that I'm going to use for aggregation and reporting. So here I have the quantity of my sales. This is saying that in January, see that's January number 1, within Washington State, I sold 5 widgets for a total price of $12.50. That's what the sales row represents. Now I've created a very simple tabular model based on these 4 tables, and I've done that using Power Query and Power Pivot, which are components that actually exist in Power BI, but they also exist in Excel. So if we go and show our queries and connections, you can see that essentially I've imported the data from these 4 different tables on this worksheet, and those were imported into a data model, which we can see here in Power Pivot. As that opens up, I can switch this over to diagram view, and there you can see our 3 dimension tables that are related to my 1 fact table. So if we look at these relationships, you can see that the month number, which is my key in the month table, corresponds to the month number in the sales table. There's the location ID, location to location ID, and then product on the product ID. So really simple stuff with these 3 dimension tables and 1 fact table. A very, very simple example of a dimensional model, or what we would call a simple star schema. imagine that there were 5 tables and they were surrounding the sales table. It would look a little like a star. All right, well, since we have this in a data model, it means that I can actually interact with this data. And I've done that by creating a pivot table on this worksheet. So this pivot table that I've created is based on that data model. And I can look at the field list for that pivot table, and here I can see my location table, month table, product table, and my sales table that has some measures in here. Now, we're going to talk more about measures, but I want you to look at this very simple measure. This is my units sold measure. If we go over to our formulas, here you can see the DAX for my units sold measure. This is a very simple measure that is just saying the units sold measure is just the sum. It calls the sum function in DAX for the quantity column in my sales table. Let's not worry about the rest of these for now. But as you can see, if I drag and drop that measure down into the values for my pivot table, I get a total quantity of 195. So if we were to add up all of the numbers in the quantity column, they would add up to 195. Really super simple stuff for this simple example before we really get into the weeds. Now, I haven't filtered any of my dimension tables yet. Therefore, I get the total for the entire sales table. Now, if we jump over to this example, on this worksheet, I have another pivot table. And I've actually filtered this pivot table based on the rows that you see highlighted in my tables here in this worksheet. So I've dragged the month name, the state, and the product name fields down into the filters for my pivot table. And I've used the filter drop-downs to select February, Oregon, and Sprocket. So you can see those highlighted here. So question, what is the row context of my month table? Simple answer. The row context of my month table is month name is February. Okay, because the month name is February in this month table, which is related to my sales table, the sales table through filter propagation, meaning I have filtered this dimension table, which is related to the sales table. Therefore, I'm going to filter all of the rows in the sales table down to February. That's number 2. Okay, so at this point, these rows are in context. That would be the filter context of the sales table if I were only filtering it by February. But I'm also filtering by Oregon. So we take our February rows and we look only for where the state is Oregon. That's location ID number 2. All right, and then we're also filtering for the product Sprocket. That's C. That's what that one right there. That one right there. So we're only going to get the intersection of these 3 different columns, which means that my filter context for the sales table is now 2 rows. That row and that row. Then if I apply my units sold measure, which is the sum of quantity for those 2 rows, 3 and 3 are 6. Okay, simple stuff. So we've got row context, we have filter context as a result of filter propagation through this relationship, and that performs that filtering and calculation. Let's take a look at a slightly more complex example now. Here our month table is filtered by January, right there. Our location table is Washington and Oregon, multiple items. And we are not filtering the product table. And since we have not explicitly filtered the product table, that means that there is no row context for the product table. Therefore, no filter is applied. So let's just work the filter logic now. Month number is 1. There are all the rows where month number is 1. Additionally, location ID is 1 or 2. So we're going to include all of those rows where location ID is 1 or 2. Now we're down to these rows. We don't have a filter on the product table. Therefore, the filter context of the sales table are these 6 rows right here. If we were to add up the quantity, we would get 61. Okay, easy stuff. One more example real quick. This should be real easy for you now. The row context of the month table is January and March. Okay, so I'm filtering the month table on January and March. That's going to propagate over here. We're going to have January. We're going to have March. Okay, we have states Washington and California. There's Washington, number 1. Here's California. Here's Washington. Here's California. And then product is gadget or B. So if we go down here, you can see that here we have a row that qualifies. Here we have a row that qualifies, but we don't have any rows in the month of March that meet the same criteria. Therefore, there are only 2 rows in the sales table that meet that criteria, which means that the filter context of the sales table is that row and that row. 7 plus 6 is 13. Okay, done with that. Let's move on to the next concept. Now, before we jump over to Power BI from Excel, I just want to finish up a few basic concepts here in Excel. So you've seen that we can use pivot tables with measures and fields. And so let's just do that. I'm going to grab my product name and I'll put that on rows. You can see I already have the units sold measure here. And so here you can see that I have each of my products on the rows in this pivot table, and then the units sold measure is calculated for each of those rows. And so that actually creates a row context for each of my products, and then you can see how the measure is calculated. We can put some other measures on here as well. Let me just show you where you go to create measures in Excel Power Pivot. Here on the Power Pivot ribbon, here, this is where you can define all of your measures. So I just create a new measure, and I can name that measure and add a formula here. Now, this is much easier to do in Power BI, but I just wanted to show you where you can go to actually create your measures. There are really 2 objects that are typically used to define calculations in Power Pivot or in Power BI, and those are calculated columns and they are measures. We're not going to be talking about calculated columns so much because it's a much less flexible type of calculation. The reason for that is that a calculated column is restricted to the row context of a single row within a table, which means that though it's possible to reference other rows in that table, it's really not something that's typically done. And so there really is a limited opportunity to use calculated columns when compared to measures, which is what we're working with here. Measures have model-wide scope. Even though a measure lives in a table, all of these measures were defined here within the sales table. And the scope of that measure is that it's calculated against anything that you slice it by or group it by. Therefore, measures are far more flexible. So let's just look at a couple of the measures that I've already defined. We'll go ahead and hit the edit button there. There's my units sold, which you've already seen. It's really just the sum of the quantity from the sales table, just like that. This is the basic measure pattern when you're creating measures. A lot of your measures are going to be very simple. It'll just be the sum of something or the average something. And so those measures will always simply aggregate using natural filter context of a table. It's just going to take the rows in a table and for a particular column and is going to sum them up. And if you filter that table, then that natural filter context is applied as you slice and filter. And then you can alter the natural filter context. Here is an example where I create a measure called units sold PNW for the Pacific Northwest. And here we're using the calculate function to calculate the sum of the sales quantity, but we're going to alter that natural filter context with this expression that says where the state is in or is one of these values, Washington or Oregon or Idaho. And then you can override the natural filter context by using a number of different DAX functions. In this example, the all function, and you'll see an example of this. We'll show you this one. So here's the units sold for all of the states that we have available in the location table. And let's go ahead and use that measure so we can see what that looks like. So if we go down to our sales table right here, here we have units sold in all states. We'll pull that down into values. So there you can see, let's put the state on here instead of the product name. So we'll put state on rows. And there you can see the units sold in Washington state, and then the units sold in all of the states, which really is the total. And we would do that if we wanted to be able to see the contribution of this value to all of the states. And I've created a measure to do that called units sold state contribution %. And so you can see that that number is 33.3% of that number. All right, let's move over to Power BI, which is actually a much easier environment to work in to define measures. All right, so let's talk about how we create measures in Power BI, either here on the report canvas page, which you can get to with this icon right here, or in the table grid pane. You have the ability to walk through all of the fields here, and we can expand a table and either use the ellipsis on the table to add a new measure, or on the modeling tab or the table tools tab here, you can click new measure to add a measure. So we've seen the sum function at work. There are a short list of what we call aggregator functions. And this simply means that this is a function that takes the value from multiple rows in a table and it aggregates them. It either sums them up or calculates the average, returns the min value, the max value, the count, etc. And these are processed over all of the rows in a table according to the filter context of that table. In this case, we were looking at the sum of the quantity column in the sales table. And you've seen how that works with various filtering and slicing. Now, there's another set of functions that are called iterator functions. And the difference between an aggregator and an iterator is that rather than processing the sum or the average or some kind of aggregations for all of the values in a column for a given table, this processes an expression one row at a time with a result for the entire table. Let's say that our business stakeholder has defined a report requirement. They need a report page that shows the average order price at various groupings and in various ways within a report page. Let's go ahead and say that we have a report page that they've provided requirements for. We're going to put this header up here that says this is the average order price report. And according to our understanding of the requirements, as stated by our business stakeholder, the average order price is the total price divided by the sales quantity. Okay? Simple stuff. All right? So let's create a measure that does exactly that. So we're going to create a new measure called average order price. Now I'm going to put a 1 after it because we're going to calculate this measure in a couple of different ways. And we know that we need the sum of the sales total price. All right. And we're going to divide that into, let me be consistent with my formatting here. Just for readability, I'm putting spaces around that. And we're going to divide that into the sum of the sales quantity. Okay, so that's a really simple calculation. Now remember that I'm just thinking out loud or typing out loud, and if I drag and drop that onto my report, show it in a table, then I do get a value. It's 173, but let's do this by month. Well, bump up my font size to 18 like we did before. Okay, so that you can see for each of my months, I'm taking the sum of the total price and I'm dividing it by the sales quantity. Now you remember that rather than using the /, we use the divide function, which automatically takes care of divide by 0 problems. So let's just get rid of that slash. We'll do it the proper way. I'm making a point to put spaces around things so that it makes my code a little more readable. But that's a very simple function, and you can see that I want to make that a decimal number, and I'm going to go ahead and just accept the default formatting options just in case that were ever in the thousands. Then we'll add a 1,000 separator. But that's super simple stuff. Now, this calculation works against rows in the sales table, but we're grouping by months. So what I would like to do is actually expand this table visual out to the detail rows in my sales table. And you'll recall that I have one row in the sales table for every combination of month and state and product. So theoretically, every row in this table visual represents a row in my sales table. All right, so you can see that in January in the state of California, for gadget sales, my average order price was $3. For Gizmo sales, it was 50 cents. For Who's It sales, it was 75 cents, etc. Okay. Now, when we go down to the bottom, we look at the total. If we look at the context of this total, essentially what we're saying is forget about all of the details. Just go calculate this again at the grand total. Forget about the month, forget about the state, forget about the product, and just take the sum of the total price and divide that by the sum of the quantity. And for that, we get an average value of $1.73. Okay, good stuff. Now, let's try this again using another method. So I'm going to create another measure, and this time I'm going to use the average x function. So let's give this the same name, average order price 2. And this time I'm going to say I want average x across the sales table. So you can see here that this iterator function takes a table. It doesn't have to be the name of a table. It could be a function that returns a table, and that table object could be summarized or grouped somehow in a more complex expression. But we're going to take every single row in the sales table, and one by one, we're going to calculate an average, and then take that average across all of those rows. So there's my table, and my expression now is going to be that we want to divide the sales total price by the sales quantity. Okay, so there's my close parenthesis for the divide. There's my close parenthesis for the average X. Press enter. We'll go ahead and format this the way that we want. And add that to my table visual. So you can see that for January California Gadget, we get $3 using this different calculation. For January California Gizmos, we get 50 cents. Same value all the way down until we calculate the total. And notice that at the total level that the numbers are different. It's a different interpretation of the business requirement. Okay, the requirement given to us as take the total price and divide it by the sales quantity. In one case, I'm taking the sum of the total price and dividing it by the sum of the sales quantity. In the other calculation, I'm taking the total price of the detail row, dividing it by the sales quantity at the detail row, and then taking the average of those values to my totals. Now, you can see that the numbers are the same at the detail level, but if we group our table differently so that it's not at the detail level, so if we take out state, for example, notice that my totals are not, hold on a second, let's just take out the month. All right, you'll notice that my numbers are not the same. Okay, different interpretation of requirements. That's the purpose of the average X function. In summary, measures are calculated in the filter context of a table. There's always context, and there will always be a filter context. The filter context might be there are no filters, or the filter context might be that you've selected a month, or you've selected a combination of months, you've selected a product, you've applied a filter, you've sliced, you've cross-highlighted by clicking on another visual on a report page. All of those things alter the filter context of a table and yield different calculation results for measures. Row context is the row of a table that's used for grouping, filtering, and slicing. The calculate function applies filters to an expression. Like we've seen, calculate can be used to override natural filter context, and it can be used essentially to transition or convert row context from one table into the filter context of another table. Example again is that I have grouped by month, so the row context of that grouping is January on the first row, then February on the second row, then March on the third row, and then a calculation, a measure placed in the cells on one of those rows takes that row context and creates filter context, which then performs the calculation. You can override natural filter context using a variety of DAX functions. We use the all function as a very simple example. You can apply that in more advanced ways. Aggregator functions like sum and average are processed over all of the rows in a table according to the filter context that you apply on that table, but they're just applied to all of the rows and is simply added up or aggregated. Iterator functions are processed one row at a time for the table that you've passed into the first argument of the SumX or the average X function. And then that aggregation is applied to the total for the entire table. The example that we applied was average X, where we performed division for every single row in that table. I hope that this has been helpful and educational for you. So once again, check out my blog at SqlServerBi.blog, and you can follow me, and you can also post comments and provide feedback and ask questions on my blog as well. I'm occasionally active on Twitter. I tweet at Paul_Turley, and also on LinkedIn. I'm not always super responsive through LinkedIn, but you're welcome to reach out to me there. So once again, thank you for watching.